Hi guys, my name is Peter C. Dogwa Jr., mathematics instructor at the University of Liberia and your math tutor. So in my today's video, I will be discussing mathematics, but particularly matrix algebra. So matrix algebra is a kind of sweet math, very sweet, that you will enjoy doing. So I want that you follow our videos so that you have the total understanding of matrix algebra, its theories and application. So to begin with, we want to look at the basics of matrix algebra, particularly the basis of matrix and the definition of matrix, the elements of matrix, the rows and columns of matrices, the name of matrix, order of matrix, position of elements of matrix. So what is a matrix? So we said for short, matrix is an array, kind of arrangements of numbers, of letters, of characters, and so forth. So it's defined as an array of numbers. It is also simply called a rectangular arrangement of numbers, letters, characters, and so forth. But it's not, it's just not always referred to as rectangular arrangement, because it is not always in a rectangular form. No, it can be in a square form. So it doesn't only have to be a rectangular form of arrangements. So we said we have an example on the board, matrix A. So this name of the name of this matrix is matrix A, and we named matrix using boldface capital letters. So we have a boldface capital A. So the name of this matrix is matrix A. So matrix A is A sub 1 1, A sub 1 2, A sub 2 1, A sub 2 2. So we attached these numbers so that we define the position of each element within a matrix. So the position of the first element this means that this element is in the first row and the first column. So the first represents the row like we have here, and the second represents the column. So this is a row, this is a row, this is a column, this is a column. So we have row 1, row 2, column 1, column 2. So this indicates the first row, the first column, the first row, the second column, the second row, the first column, the second row, and the second column. So this explains how you can easily identify an element, or position within a matrix. So elements of a matrix, normally we use small letters to represent the elements of a matrix, and to represent the name of the matrix, we use capital letters. Additionally, we also have the rows and the columns. Okay, we just talked about that. The name of a matrix, you can use capital letters or you use boldface letter. Now, the order of a matrix has to do with the dimension of that matrix. So, for instance, if we had matrix B, which is like A, B, C, D, E, F, for example. If this is matrix B, then we must first identify how many rows are within matrix B. So we have row 1 and row 2. And also how many columns. So we have column 1, column 2, and column 3. So based upon the rows and the column of this matrix is named, or the order of this matrix will be a 2 by 3 order, or the dimension would be 2 by 3. So if they ask you what's the dimension of this matrix, is equal to a 2 by 3 matrix. Or if they ask you what is the order of this matrix, it is a 2 by 3 order matrix, right? So if this matrix was in this form, A, B, C, D, E, F, and this was matrix C, it means it is no longer a 2 by 3 matrix. So we calculate, remember the row is first and the column next. So it's 1, 2, 3. So it's 3 rows, row 1, row 2, row 3, and then column 1, column 2. So we have 3 rows. So the dimension of this matrix, dimension is just equal to a 3 by 2 matrix. So there's a 3 by 2 matrix for the dimension of the matrix. Now, we said matrix is an array of numbers, letters, characters. Now, when we say numbers, letters, characters, and so forth, we mean that the elements of a matrix can be numbers, like you have, or you can have 1, 2, 3, 4, for example, matrix A. You could also have letters, like we have in matrix B, A, B, C, D. You could also have characters, matrix C. You have, like I say, times. I have plus, I have minus, I have divide, and so forth. So as long it is a kind of orderly arrangement of rows and columns, that is referred to as a matrix. So one thing I also want to say is that we don't always use parentheses to, diagram a matrix. Like the way for set, we don't always use for the universal set. We don't always use cycles to represent maybe the combination of 2 or more sets. We can also use square boxes. We can use rectangular boxes. And also for this universal cycle, let's say universal set, the one that is enclosing the group of sets, we don't only have to use kind of rectangular box or a square box. No, you can use a cycle as well, and so forth. Likewise with matrices. So it is not binding that you use brackets. You can use parentheses. So you can say set A is equal to 1, 2, 3, 4, 5, 6, and so forth. It still represents a set. So thanks ever so much for watching. So before I leave, I just want to mention one thing. In every given matrix, the number of elements in every row must be the same in a matrix. And also the number of columns in every row, the elements in every column must be the same. So this is row 1. Row 1 has 1, 2, 3 elements. In the rest of the rows of this matrix, you must have 3 elements. Now the elements, they don't have to be the same. They can be different elements, but they must be the same number of elements. So you have 3 elements. Now what if you have this to be matrix B? So this is not referred to as a matrix because in row 1 we have 3 elements, and in row 2 we have 2 elements. So this is not called a matrix. So the rows must have equal number of elements, and the column must also have equal number of elements. So thanks ever so much for watching. See you in our next video. Thank you.